let's chat about balance. This is going to be really simple, like seriously simple, okay? So, for the balance, you have two organs. It's going to be simple because we already learned about the hair cells, okay? So, balance. You have two structures that work here. We're going to start with the vestibule, which is sensing linear acceleration. Essentially, we're talking about this, 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 or this. It makes sense, and it's important to understand that we are sensing accelerations. If your body is moving at a constant speed in a linear fashion, you won't be able to and you can't see anything, you won't be able to tell whether you're moving or not. Okay? If you've ever been in a plane, when windows are closed, you can't really tell if you're flying. So far, so good? So, vestibule is the part of the bony labyrinth. So within vestibule, you have utricle, which is sensing horizontal accelerations, and saccule, which senses vertical accelerations. We good? So you need both of them to sense all spectrum of linear accelerations, but utricle is specifically horizontal, saccule for vertical. So here's how it works. Basically, very similar to the hearing. So you've got hair cells, right? And their stereocilia are embedded in so-called otolith membrane. Now, why the name is otolith? Oto refers to ear, lith refers to stones. So otolith membrane is very rich with calcium carbonate. Are you following me? Like little stony crumbles that make this membrane very heavy. Now look what happens. Again, hair cell, otolith membrane. Look what happens. When you start moving, otolith membrane is heavy and it has high inertia. So you start moving, your hair cells move, but otolith membrane does not. Are you following me? In the same fashion, like if you sit in the car and you push the accelerator and you're going to do this, look, you can do this, right? Like your body moves forward, for instance, because you have seatbelt on, but your head's kind of whiplashes back because it's not attached to the car seat. Are you following? Well, when hair cells move, so movement of hair cells results in the bending or deflection of stereocilia, and mechanically gated potassium channels open. And I'm going to do basically same story as with hearing. Are you following me? Okay, does that make sense? So potassium channels open, hair cells depolarize, calcium flows in, results in the release of neurotransmitter. Does that make sense to you? Now, so this structure right here, this whole thing. It's the sensor. Like in the ear, the sensor was organ of Corti. Are you with me? Here, the name of this sensor is macula. Okay? This hair cells with the hairs embedded in the membrane is macula. Question. The answer is on the board. So this macula that I drew here, where is it? Is it in the utricle or is it in the saccule?
Utricle.
Huh?
The utricle.
Bravo. It's horizontal. You're absolutely right. In the saccule, it would be like this. That makes sense? That idea. We good? Any questions on linear acceleration? Good? Okay. Now what about semicircular canals? They sense rotation. Are we cool? How? First of all, if you look at this model, you can see that semicircular canals are in 3 planes. That makes sense? Why? Because we live in 3-dimensional world, and we can rotate so they can sense rotations in all 3 dimensions. Overall, that makes sense? Because we're not moving like in 1-dimensional. So this is how it looks. You have this wonderful picture. I am going to draw my version, but it's not really much to add. So if you would look within the canal, there's going to be semicircular duct. Within the duct, so that's the duct. Semicircular duct. You have hair cells. And the hairs are embedded into gel-like ampullary cupula. Okay. This whole sensor here is called crista ampullaris. So guess what? When we start rotating, the canal rotates, the fluid, the endolymph moves, bends ampullary cupula. You following me? Yes, no, not sure. If you want a demonstration, there is a wonderful segment on, you may or may not be familiar with a TV show called Top Gear on Amazon. Same people that ran Top Gear, it's basically a car show. They did a grand tour, phenomenal project. And in one of the episodes, they had to transport fish from an ocean shore deep into the continent. Don't ask why, it's very funny. But one of them installed a giant aquarium inside the car. And lo and behold, when it starts moving, the water goes the opposite way. Does that make sense? When he starts braking, the water keeps going forward. So this is what happens when you're rotating. You're rotating and endolymph moves and bends ampullary cupula. It bends your stereocilia. Mechanically gated potassium channels open. There you have it. Clear? This is all really, like, that's it. Make sense so far? Diseases of balance. So you've got Meniere's. So in this case, it's pretty sad. You have accumulation of fluid inside of the membranous labyrinth. Okay. So membranous labyrinth becomes swollen, and here's the main problem. So imagine that. So your vestibular apparatus is supposed to send you signals about your position in space, right? And when it screws up, you develop things like vertigo and motion sickness. So imagine having motion sickness all the time. Kind of sucks, right? Now, motion sickness it's kind of interesting, but exact mechanism of motion sickness is unknown. What we presume happens is this. Let me ask you your experiences. You all drive cars, right? When you drive a car, when you are a driver, do you develop motion sickness? If you are sitting in the back seat, doom scrolling through your Twitter feed, while you are driving, importantly, in the city, with stop and go traffic, can you get a motion sickness?
Yes.
Fairly easily. Here's why. Well, here's what scientists think why. Because when you're driving, the signals from your vestibular apparatus about stop and go, and the signals from your eyes about stop and go, they match. Got it? When you're looking at the phone, your eyes tell you that you're not moving. Your vestibular apparatus tells you otherwise. Does that make sense? This is why one of the treatments, for instance, for motion sickness on the ship is to get kind of outside on the deck and follow the horizon as ship rocks on the waves. That makes sense? I mean, and then for some reason, this is the unknown part. For some reason, this mismatch in sensory inputs triggers the release of neurotransmitters from vomiting center in medulla oblongata, and you start vomiting. Okay? Any questions in this one? Okay. Any questions about balance? No? All right.